Hi everyone. Today I want to be showing you the dimension of physical quantities, how it is applied to physical quantities as far as physics is concerned. Now I've been able to bring out the definition of physical quantities. Now, the dimension of physical quantity is the physical nature of such quantity. It is used to show the physical nature of a quantity in real sense, as you have seen it here. Now in physics, we have, well, for this particular level we have seven basic quantities, and each of them we have their dimensions. Actually we could have others as well, which I don't know. So the basic quantities, also known as the fundamental quantities that we'll be focusing on, are the mass, length. We have length, we have time, we have thermodynamic, temperature, thermodynamic, temperature. We also have electric current, and we have amount of substance, amount of substance. Then we also have luminous intensity, luminous intensity. Now these are the basic physical quantities that we're going to focus on, and each of these physical quantities has what dimension. For example, the dimension of mass is given, the symbol for the dimension rather is given as capital M, like this. That of length is given as capital L. That of time is given as capital T. That of temperature is often given as theta, right? Then that of electric current is given as capital what? I. This I is too big. Is given as capital what? I. Then amount of substance, the dimension is often given as capital N, while luminous intensity has a dimension given as what? As this. Now these are the seven basic dimension of physical quantities we have. Now there's something you need to know when talking about dimension. I put it under note here, right? Now I'll just focus on the mass, length and time. Any physical quantity, right, that carries the unit of mass, right, as the dimension of what? Of mass. How am I talking about? Any physical quantity that carries the unit of mass. Recall, what's the unit of mass? Recall, mass is what? Measured, as far as physics is concerned, measured in what? In kilogram, right? Kg. So any physical quantity that is measured in kilogram, we have the dimension of what? Of mass, which is capital M. It is always in square bracket. Sorry, I didn't put it here. They are all in what? Square bracket, square bracket, square bracket, square bracket, square bracket, square bracket, and then square bracket. So any physical quantity that carries the unit of mass, once it is measured in kilogram, it has the what? Dimension of mass. The same thing applies to what? Length. Any physical quantity, any physical what? Quantity, right, that what? carries, right, the what, unit of what, of length, right, as what, the dimension of length. So which implies that in physics, length, recall, I'll just do this too, length is measured in what, length is measured in meters, and small m, but the dimension is what, capital what, the dimension is capital L. Don't forget, dimension of length is what, capital what, L. So the same thing applies to what, temperature. Anything measured in degree Celsius, degree Kelvin, right, it has the what, dimension of temperature. So in the next video, I'm gonna be looking at how we can deduce the dimension of physical quantities, and how we can know if a physical quantity is dimensionally correct. There are some physical quantities that we use that are not really correct dimensionally. I get it. So we can use dimension of physical quantities to show the correctness of an equation. I hope this video helped. Subscribe to this channel and expect more videos. Thanks. See you in the next video.